our next speaker is Hedwig Lankau. Hedwig is the bioacoustic equipment manager for the bioacoustic unit at the University of Alberta. She now manages hundreds of autonomous recording units, ARUs, for the bioacoustic unit field program. She develops ARU field deployment and maintenance protocols, creating new versions as new equipment is available. So somebody that's kind of very, very qualified to and has put out probably more ARUs than we've had hot dinners. Her talk is called Large Scale ARU Deployment. I'll hand you over to Hedwig.
Hello, I'm here today to talk to you about large-scale ARU deployment in Northern Latitudes. My name is Hedwig Lankau and I live in Edmonton, Alberta, Canada. I have worked for the bioacoustic unit for 9 years. I started working with autonomous recording units, or ARUs as we call them, in 2012 when my supervisor asked me to buy 25 SM2 song meters from Wildlife Acoustics and learn how to use them. We put ARUs at about 200 locations in northern Alberta that summer. As we enter the 2021 field season, I am managing over 700 units for the bioacoustic unit field program, and our sister program at the Alberta Biodiversity Monitoring Institute has 1,000. These ARUs are going out to thousands of individual locations across Alberta. They are deployed for varying lengths of time, ranging from 1 day to year-long deployments in remote locations. Our ARU fleet is composed almost entirely of song meters from Wildlife Acoustics. We started with the SM2s, and most of those original 25 are still going into the field this year. We use the SM3s primarily for sound triangulation because they pair well with the GPS receivers. The SM4s are the backbone of our monitoring program. Last year, we started using the Song Meter Mini, and we're looking forward to trying out the micros this year. In fact, we just got a few of them last week. In addition, we have some BAT ARUs. We are getting more of those as we expand our ultrasonic surveys. Over the years, we've faced many challenges in ARU deployment. In the field, we deal with difficult terrain, inclement weather, forces of nature, transporting hundreds of ARUs, collecting metadata, and dealing with wildlife and livestock. In the office, we have to keep track of hundreds of ARUs, keep them in working order, and track the metadata linking individual ARUs to the data they collect. In response to these challenges, we've developed many solutions. In the field, we focus on having trained staff to do ARU deployment and basic maintenance. We develop site and study specific solutions. We have created minimum metadata standards and use standard field protocols. In the office, we have a relational database for tracking all ARUs. We do regular equipment inspections, measure microphone sensitivity, and do in-house repairs. We also value strong manufacturer support for more detailed repairs and firmware updates. I need to go where? This is something we and our field staff ask ourselves at least a few times each year. In Alberta, we have much different terrain and vegetation cover, ranging from open grasslands and agricultural land to mountains, dense forest, and boreal wetlands. In addition, we do field work across all seasons, from cold, snowy winters through the spring melt and in the summer and fall. For example, the flooding creek in the lower right-hand corner was a small frozen stream that could be crossed on foot a few weeks before the photo was taken. On this particular day, retrieving the ARU 30 meters on the other side required an extra 2-hour detour compared to when it was first put out. The varied terrain and ground and weather conditions require us to use a variety of modes of transportation. In addition, there are many remote areas with few to no roads. We do a lot of hiking with backpacks full of ARUs. Snowmobiles, ATVs, trucks, helicopters, boats, and canoes have all come in handy for reaching our study sites. One crew even used fat bikes one year when the very dry conditions and the resulting fire ban prevented us from using ATVs. Cold winters pose some unique challenges, especially when temperatures drop to -20 degrees Celsius and below. While the ARUs run in cold temperatures, they are not as easy to set up because the the LCD screens get frozen. Rain, wet forests, and soggy wetlands also pose risks because we don't want water getting inside the ARUs or microphone ports. Our solution to both cold and wet conditions is to reduce or eliminate opening the ARUs in the field as much as possible. Instead, we set them up in the office, in our trucks, or in the field camp. They are often pre-labeled with the location they're going to. The delayed start function is very useful, both for dealing with inclement weather and supporting large-scale deployment. Using this, we can set up large numbers of ARUs in the office, take as much time as needed to get them out into the field, and still have them all start at the same time. The boreal forest is full of curious critters. Some are large, like the black bear checking out the SM2 on the right. Some are small, like the rodent that chewed the port cover in the upper middle photo. We've even had caterpillars chew off the windscreens in some years. In spite of this, we have relatively few losses to wildlife each year, maybe 2 or 3 out of thousands of units deployed. We started off locking all of our units in the first years, as you can see in the photo with the bear, but we found that that was not actually necessary because they rarely got carried away and they didn't get taken off the trees. The only exception was the one time a bear took a bag of 4 SM4 units off an ATV and we never found them again. When it comes to animals interfering with our equipment, livestock is by far the greatest challenge. Cows in particular are very curious and like to investigate ARUs by chewing on them or using the stakes as scratching posts. Here are 2 of the ways we keep livestock off the ARUs. On the left is a low metal case that is staked to the ground, good for out in the prairies or open pasture and for summertime. The holes in the metal allow the sound to reach the microphones from all sides. On the upper right, you can see an ARU on a stake surrounded by a wire agronomy cage, and this also works fairly well. While trees and posts are the easiest things to attach ARUs to, they are not always available. Keeping ARUs out across multiple seasons is also a challenge because when the ground thaws in the boreal wetlands, it can sometimes be very unstable. The tripod and stake setup on the left is one of our solutions to this. This station was set up in the winter when the wetland was frozen. The stake was drilled into the ground. As the ground thaws, it might be too unstable to support the stake. This is where the tripod comes in. As the snow melts, it settles down onto the ground, distributes the weight, and keeps the stake upright. We found the stake and tripod combination useful in the mountains as well, and we also use it on our bat deployments where we use the tripod to stabilize poles to get the microphones high up in the air. Here's another example of creative problem solving by my colleagues. We had to get many ARUs into a remote wetland without road access in a very short time. We put the ARUs on stands that could be set down in the wetland using a helicopter with a long line, as you see in the photo on the left. Using the helicopter saved our staff the time and effort of hiking kilometers in hip waders. The stands were also very good for keeping the ARUs upright on unstable ground. Later in the summer, the helicopter also flew staff in to collect the ARUs and stands. Consistent staff training is an important part of our program. We provide training to all of our new staff and refreshers for our existing staff. We have standard protocols for deployment and maintenance, and we share these on the Bioacoustic Unit website. We also provide training for collaborators and communities running their own ARU programs. This contributes to consistent deployment methods and data collection across Alberta and other parts of Canada. Consistently collected data can be more easily used for sharing and doing large landscape scale analysis. Our ARUs go through a similar cycle at least once a year. This starts with the pre-field setup, which is what we're actually doing right now. This is when we put in batteries, update the firmware, load the settings file, and put in memory cards. As the ARUs are deployed and retrieved, they're inspected before they're deployed again. If ARUs are moved from one station to the next, field staff give them a quick once-over, but at least once a year, they are back at the office and are checked over completely. Our ARU inspection has 2 main components. assessing the physical condition of the ARU and testing the microphone sensitivity. The physical inspection usually has one of three outcomes. The ARUs that do not need repairs are ready to go back out into the field. Those with minor issues are repaired in our workshop before being used again. The ARUs with damage that we can't fix are sent back to Wildlife Acoustics. The few that are not repairable, we remove any useful parts and retire the rest. All microphones have their sensitivity checked at least once a year. Those within the correct range are ready for deployment. Those that are low sensitivity, broken, or not working are repaired or replaced. Here are some examples of the type of damage we see on our units. Minor issues include things like missing or torn windscreens, rodent damage, or the broken pressure vent. We also replace any broken microphones on the SM3, 4, and mini ARUs. Major damage includes anything related to the wiring or housing. We pay particular attention to things that might impact recording quality. If there's any damage to the motherboard or mic connections, we send the ARUs back to Wildlife Acoustics for repair. We also pay attention to anything that might make the ARU not waterproof, such as damaged seals. Of course, there's no fixing these lumps of charcoal. Sections of the boreal forest burn every year, and we lose some units to that. Fortunately, our study areas are spread out, and that lowers the risk. Other than having study sites spread out, there's little we can do to avoid forest fires. However, because fires move quickly, the units are sometimes not completely burned, and we sometimes still get the data back. We have a standard set of tools and spare parts on hand. Our field staff carry a spare parts kit, especially if they're doing remote work, so they can easily replace windscreens. And snap ring pliers are essential for that task. The pulse load battery tester is also super important. We use it to check the battery life when we move ARUs to make sure that they will record as long as needed. Finally, the calibrators are essential for monitoring microphone sensitivity. We currently use both the X-Tech and Cirrus model calibrators. We got the Cirrus model for the SM4 units because the calibration port is offset and fits over the left microphone more easily. So what is microphone sensitivity and why does it matter so much? Sensitivity is a measure of how well a microphone detects sound and how far it can hear. A more sensitive microphone will pick up softer and farther away sounds. Microphone sensitivity decreases over time with exposure to the elements, in particular moisture, and from general wear and tear. We measure microphone sensitivity in decibels. Less negative numbers equals higher sensitivity, and more negative numbers equals lower sensitivity. On the right is the data from one SM4 unit over 4 years. You can see in year 1 that the left and right microphones have approximately the same reading. Over the next 3 years, the sensitivity decreases slightly. However, in the last year, you can see a large difference, about 7 decibels between the left and right microphone. The left mic is also much lower than the year before. These data tell us that it is time to replace the left microphone. Changes in microphone sensitivity have a direct impact on file quality. We use stereo recordings because they give us additional information to differentiate individual birds of the same species. For example, imagine that you have 2 white-throated sparrows that are both singing 50 meters from the station, but from opposite sides. Using the stereo recording, you can hear the difference even if the birds are singing at the same volume because you can hear from both directions. By making sure that both mics on the same ARU have the same sensitivity, we ensure that any differences in volume are due to the bird's position, not to the microphones. We also find that old microphones have other issues like excess static that can reduce recording clarity. Finally, microphone sensitivity directly impacts the sampling radius and the total area you are surveying. A microphone that has extremely low sensitivity will record fewer birds compared to one that is within the normal range. And the normal range for microphones depends on the microphone itself and on the manufacturer specifications and on the calibrator used. Minimum metadata standards are another key component of our program. This includes information like unique location names, deployment date and time, latitude, longitude, ARU ID and model, microphone ID, and memory card numbers. The location name is very important because this is what we program into the ARUs for the file prefix. We have millions of files on our server, and these are uniquely identified by the location name and the date and time stamp applied by the ARU. Those sound files can all be linked directly to a specific location and to the ARU used to record the data. We write down the date and time from our GPS or cell phone, and we use this to compare to the date stamp on the voice note as part of our data proofing program. The microphone ID is important for any removable microphones such as SM2s or BAT units so that we can track microphone sensitivity independently of the ARU number. We number all of our memory cards to keep track of the data when the cards are removed to the time when the files are secured on the server. Collecting all of this information supports the use of a central data repository and automated data processing, as well as tracking data from ARU deployment to the final analysis. I created this diagram to show how the minimum metadata keeps everything connected. We always start with a unique location name. For each location, we can tell which ARUs were deployed and at what date, time, and year this was done. We can also tell the microphone sensitivity and repair status of the ARU. The equipment used directly impacts the quality of the sound files and of the data transcribed from those files. When we analyze the data, we can control for factors such as the ARU model and age and microphone sensitivity. Via the location name, this system can be used to link the ARU data to vegetation data and other sensors like wildlife cameras. Our central equipment database is essential to managing the hundreds of ARUs that we have. Here we store information like purchase date, serial numbers, inspection records, repairs, and which ARUs go out into the field and when. This equipment database is currently housed on a server at the University of Alberta and is accessible primarily through a Microsoft Access front end. However, we are working on moving this equipment system onto our integrated online data system. This integrated system is called WildTracks. WildTracks is an online platform for managing, storing, processing, sharing, and discovering biological and environmental sensor data. We currently use it for managing all of the sound files from our ARUs. Here we enter field metadata, upload sound files to our central server, and listen to and transcribe the audio recordings. WildTracks is available to our collaborators, such as Environment and Climate Change Canada, and we have clients such as consulting companies that pay to use the system. Here's a quick peek at the analysis page in WildTracks, where you can see the file name and spectrogram of an individual recording. Using this page, technicians can listen to the recording, see the spectrogram scroll by, and enter the list of all species they hear. They can access their work from anywhere as long as they have a stable internet connection. We are in the process of moving our entire equipment management system in WildTracks, where we will store all of the information related to our ARUs. This will have a number of benefits. We will be able to access this information from anywhere because we will be able to use any web interface. We will also be able to offer this as an additional service to our clients and collaborators. Having a central database for ARU equipment information in Alberta and other parts of Canada will contribute to the sharing of resources and standardized high-quality bioacoustic data. For more information, you can go to these websites. At the Bioacoustic Unit site, you will find our protocols, in addition to reports and publications from the different bioacoustic research projects we've done over the last 9 years. This includes everything from yellow rail detections and nighttime owl surveys, amphibians, and gunshot monitoring at natural areas. On the WildTracks page, you can make a guest account and explore how the system works. This is where you will find our standard transcription protocols and related resources. Check out the ABMI website to learn more about this province-wide long-term monitoring program and what part ARUs play in it. Finally, if you want some fun field stories, check out the Wild 49 blog. In closing, I would like to acknowledge all the researchers and colleagues who have contributed to the information I shared with you today. I really value their hard work and ideas. I also want to acknowledge our partners and sponsors who have contributed funding, time, and ideas to our programs. Finally, I want to thank Wildlife Acoustics for their ongoing support with quality recording equipment and excellent customer service. Thank you also for giving us this opportunity to share our research with such a large audience.
Wow, thank you very much, Hedwig, for that. 1,700 units. Yeah, I struggle with my 7 units. So we've got questions coming in at the moment, probably all to do with what's your most destroyed unit, but let's see what we've got. Have you used tripods for open water like bogs and wetland deployment? And do you have any recommendations for tripod equipment?
Well, we haven't used them for outright open water, but we do use them for a whole variety of different wetlands. We were just discussing tripods because we need to buy more of them. And it's basically anything that's affordable and stable enough. And yeah. My dove is cooing in the background.
You're being sound bombed. Yes. Thank you. Can you tell us a bit more about the relational database you use to keep track of the recorders?
Well, basically, we've got a main table where we have like all of the recorder names and serial numbers, and then branching off that are tables that one of them tracks the microphone sensitivity. And so we track that for SM2 microphones. We basically we track each microphone individually because they're removable. And then for the SM4s and SM3s, we kind of treat it as a unit because you can't measure, you don't remove them. So that's all in one table. We've got one that's got the inspection information. So we've just got a list, basically of a checklist for technicians to go through so that they can do the same, make sure they're checking the same thing for each unit. We also have a list of all of our SD cards, cables. Cables get numbered. So lots of numbering, lots of labeler tape, $25 a roll. But it's super important because otherwise I don't know who took what and how many we're supposed to have and when they come back. So yeah, we're just keeping all of that in one place and trying to keep it organized. It's surprisingly hard to keep track of 100 units and know where exactly every single one is every single time and which one the bear ate.
Yeah, you've got bigger wildlife than we have. We don't have problems with bears in this part of the world, and in the UK.
So I don't know if that answers the question. Yeah.
Is WildTracks free for other scientists to use?
So I'm not the person about talk about the cost of it, but basically it's free to our collaborators and people who share data with us, basically. And then depending on what parts people use and how much, it's sort of case by case. If someone sends me an email, I can put them in touch with the WildTracks coordinator and he'll be able to answer all of those questions. And I think there's some information on the website as well.
Excellent.
So yeah, it's not free to everybody on the planet. And it just depends on how much data is shared in that. We're also have an open data initiative and there's researchers across Canada working on it. And the idea is to get as much of the, especially publicly funded data out in the open. So for example, Environment and Climate Change Canada has a mandate to get all of their data out in the open. And so for birds and wildlife cameras, we're one of what they're pursuing. So if you make an account, then you can go to the data discover part and you can see all the publicly available data. And then there's sort of gradients of data privacy from it's completely private and nobody can even know that your data is in the system to they can kind of see your locations, or they kind of know that in a general area you've done some research and they can contact you and ask for it, or they can see the locations, or you just say it's completely public. And the people, so when you create an account for an organization and you add a project worth of data, you can determine maybe you want it to be private until your papers are studied and are published. And then after that, you want it public, and then you can change the settings, and you can add people, remove them. So there's people managing the data. So there's different access levels from, the person running the organization who can delete the whole thing to transcribers who are hired and they can only access the specific recordings that they're supposed to process.
Cool, good answer. For your units, which are deployed for a year at a time, how regularly do you check they're still working and change the batteries? Do you just leave them out for 1 year and then come back to them, or do you go back on a regular basis?
Well, that depends. I mean, it would be nice to go back more regularly. The reality is some places we can only get to once a year because of the cost. So for the Alberta Biodiversity Monitoring Institute, that has the province-wide monitoring. They're using helicopters to fly in sometimes in the winter and set up units, and then they would go back in spring, do some vegetation protocols, and then collecting the units sometime in the fall or late summer. In the Northwest Territories, our partners at Environment and Climate Change Canada are doing work on winter roads, and they can go in the winter when the ground is frozen on the tundra and when they can cross all the waterways. They set them up and they can't get back until the next year. So there's basically, if we can check them, we do, and if we have the time and resources, but sometimes they're out there for a year because that's the only time we can get to them.
There's a lot of finger crossing and hoping that they're still there.
Yeah, and sometimes they're not, but I'm actually surprised at how well they often do, because we do have wildlife, but the density isn't super high. So I think it's not quite like a jungle with lots of monkeys and that around. I mean, there are bears and there are moose and there are deer and all of that, but it's just the density is not as high. When we get to areas with higher density, like we have a game reserve where, deer eating microphone is more of a problem because there's more deer. So it's partly the wildlife density is the issue. And out in the tundra, that's not as much of a problem.
How effective have you found the cattle guards? And are there other challenges you've experienced with them? Are there concerns for things like raptors perching on those guards and things like that, or is that not a problem?
I mean, raptors do perch on them, birds do perch on them, and then you get extremely loud recordings of meadowlarks, which is, we sort of warn the people listening, like when you see the spectrogram really bright, maybe pull the mic headphones away from your ears, because a meadowlark right on a recorder at like 90 decibels singing right into the mic is pretty loud. I mean, I guess that happens, but it's not like all the time. Raptors perch on them. That's more of, I guess, more entertaining when the camera is toward the top of the post, because we've got some paired arrangements and you get like 100 pictures of the raptor tail as it's preening himself. But yeah, that's not too much of a concern. In terms of how well they work with cattle, that partly depends on the pressure of the cattle. They do work relatively well, but we have some, because there's the on that specific study, there's the camera and ARU pairing. We have a lot of pictures of cows like chewing on the wire and trying to get close to the ARU, and sometimes they do succeed. I think the little cases close to the ground are fairly robust. Nothing's like 100% unless you put them high enough out of reach, but out in the prairies, and that's not an option. We're also worried about catching the wind, because out in the prairies, like the higher you have it, the more wind you're catching. I mean, there's some places there that have wind farms because of how windy it is. So that's why putting them low to ground is also like a good compromise. So it's not 100%, but it's definitely a lot better than just having them on a post and they're going to be gone when you come back.
Well, look, fantastic answers to so many problems. I think we've all experienced at least some of these during any sort of deployment that we've dealt with. Thank you so much, Hedwig. That was a wonderful presentation. I think there's probably more questions that are appearing in the chat, but we're just going to run out of time.